The last keynote speech for today will be delivered by Doctor of Engineering Ayu Purwarianti from Institute Technology Bandung, Indonesia. Now, we are going to hear the keynote speech, which will be moderated by Mrs. Alvi Syahrini Utami. Please welcome Doctor of Engineering Ayu Purwarianti and Mrs. Alvi Syahrini Utami.
Assalamualaikum warahmatullahi wabarakatuh. The honorable all participants of Second International Conference on Information System, Computer Science and Engineering 2021. I'm Alvi Syahrini Utami, the moderator of the third keynote speakers in today's conference. Before we start the presentation, I will briefly introduce to you our keynote speakers, Doctor of Engineering Ayu Purwarianti, currently is chair of the University Center of Excellence Artificial Intelligence on Vision, Natural Image Processing and Big Data Analytics at Institut Teknologi Bandung. And she received her bachelor and master degree from the Department of Informatic Engineering, Institut Teknologi Bandung, and the Doctor of Engineering from Doctoral Program of Information and Computer Science, Daihachi University of Technology, Japan. The presentation will be held for 30 minutes, and then we will have a discussion for 15 minutes. Please welcome our speaker, Doctor of Engineering Ayu Purwarianti, to deliver the presentation.
Assalamualaikum warahmatullahi wabarakatuh. Thank you, Ms. Alvi, for the introduction. So I have about 30 minutes, right? So I hope, we can all now still in good spirit. Okay. May I share my screen? Hello, Ms. Alvi. Okay. Okay, thank you very much. So for this opportunity, thank you very much for the opportunity. So for this event, I would like to discuss a little bit about our work in the IndoNLU, which is a benchmark and resources for evaluating Indonesian natural language understanding. This is a collaboration work between ITB and also University of Indonesia and also UMN, also Hong Kong University of Science and Technology, PROSA and Gojek. The idea is that we built a resource for Indonesian natural language understanding, which is easily used by other researchers. So we want to share that resource for other NLP, NLU researchers in order to push the research in Indonesian NLP further. Okay. Let's go to the first slide. And okay, this is like introduction about the natural language processing. Natural language understanding itself is a part of the natural language processing, which process text input, and then the output can be anything. Can be a knowledge graph, it can be a document summarization result, can be dashboard, can be a score, can also be a text. But if it is a text, usually we call it a natural language generation. So when we make tools or a task for the natural language understanding, we need the step of the word representation model. There are several word representation model. The basic one is the back of words model, usually used by the vector space model, where a word is represented by only one score. in the next representation model, in this kind of model, the one-hot representation, distributed representation, the representation is not one word by one score, but one word is represented by a set of score or a factor. So for the first one, it is a one-hot representation. Every word is only represented as 1 in a factor of 0. So it's very sparse data. And then for the distributed representation, we can divide it into 3 types: the co-occurrence matrix system of term, and then dimension reduction and word embedding. So nowadays, the state of the art is the word embedding as the word representation model. So here, our work is in the word embedding with contextual word embedding, or sometimes people say like contextual language model, which is, there are several algorithms in it. So what we have built is the first one here, BERT. Okay, so we want to declare that we think that this is the first ever fast resource for training, evaluating, and benchmarking on Indonesian natural language understanding tasks. There are several natural language understanding tasks we conducted using this word representation model, the BERT, the Indo-BERT. So as we know that Indonesia is the 4th largest internet users, it's very big, 171 million, very big. So I think it is very useful if we have this kind of resource for doing the natural language processing. There's some issues in the Indonesian NLP research. First, there is no standard, and then almost impossible, almost. Of course, it's not really impossible, but just almost, to reproduce results from existing work from other paper. And then data sets, sometimes they are either not accessible or scattered. So we have this kind of problem. So that's why we conduct this research. We gather the data set, and then we reproduce the result using the Indo-BERT. This is what we have built in this research. First, the IndoNLU benchmark. So we conducted these 12 downstream tasks using the BERT. And then the Indo4B Dataset, we collected about 4 billion words or 250 million sentences, which covers both formal and colloquial Indonesian sentences. And then the last one is the Indo-BERT models. This is the contextual models developed, and then it used the BERT and Albert architecture. So we have this Indo-BERT and also Indo-BERT Lite. And I believe this one, the Indo-BERT models, this is the one that can be used easily by other researcher doing others NLP tasks, natural language understanding tasks, other than these 12 downstream tasks. So if any of you, the NLP researcher, has a task, has a data set, you can just do the classification or sequential labeling using these Indo-BERT models. You don't have to build the Indo-BERT by yourself, because build the Indo-BERT models is quite time-consuming and also resource-consuming. So what are the 12 downstream tasks? These are the 12 downstream tasks. We use the data set which already published in other paper. It can be divided into the single sentence classification task. It is where an input is only one sentence, and then the outputs is several classes. So for example, like emotion classification, the class could be like happy and so on, sentiment analysis. This is a document level sentiment analysis, the output positive, negative, and then the other two, this one, the aspect-based sentiment analysis. It is where the results, not only the document level, it's not a document level sentiment analysis, but it is aspect-based. It means that each input can have several aspects, and each aspect has a sentiment by itself. So each document input can have several sentiment. I will describe later more detail in next slides. And then the other one is sentence pair classification task. So before is the input only one single sentence, one sentence, and then the sentence pair we have two sentences, and we want to try to see the relation between these two sentences. We have this textual entailment task. in this sentence pair classification. The next one is single sentence sequence labeling task. It is a sequence labeling where the classification is not for one sentence, it is for each token in the sentence. This is the task, the parts of speech tagging, the span extraction. This is where the result can be keywords or key phrase, and also the name entity recognition. The result is the name entity. And then the last one is sentence pair sequence labeling task. The task here is the question answering one, the factoid question answering. Given questions and also a passage as a result of the question, we can find which one is the answer of that question in the passage. Okay, we can see here that the domain is very various. There are tweets, general, automobile, hotel, wiki, news, and also the styles. There are colloquial and formal. Colloquial means the slang words. So why we try this kind of various domain and various style? Because the Indobird itself is various. It comes from several domains and also comes with colloquial and formal style. Okay, let's go to the single sentence classification task. The first one is the emotion classification. Here there are 4,000 emotion tweets and with 5 labels. So each tweet, this is the example of the data. This tweet, masalah nggak akan pernah menjauh, hadapi setelah sambut dengan penuh semangat. It is a happy sentence, so the emotion is happy. And then the next one is sadness. Ya. Ada satu pun yang nyangkut, there is no one. Okay, sadness. This is the emotion classification. And then the next task, second task is a document level sentiment analysis. 12,700 reviews with 3 labels, positive, negative, and neutral. One document with 1 sentiment class. So for example, here, for the first sentence is for the negative sentence, the second sentence is neutral, and then the third one is the positive one. Yeah, the best drink that I've ever tasted, for example, is a positive one. Okay. The next task for the single sentence is an aspect-based sentiment analysis. These both are the aspect-based sentiment analysis. But as we know, the aspect-based sentiment analysis really depends on the aspect, what kind of aspect in that task. So for the third task, the aspect-based sentiment analysis is for the car reviews. There are 6 aspects of the car quality and then 3 labels, positive, negative, neutral. This is the aspect, can be fuel, machine, others, part, price, service. So we can see here, for example, the second sentence. In the second sentence, there are 2 aspects with positive sentiment, not only 1 aspect. And that means that it can be clear that one document can have more than 1 sentiment. And then for the fourth task, it is a hotel review. It's also an aspect-based sentiment analysis with 2,100 hotel review and 10 aspects of hotel quality and 4 labels, positive, negative, neutral, and positive, negative. So there is data here where 1 aspect has positive and negative sentiment on 1 sentence. Okay, and then in the sentence pair classification, the textual entailment, the input is, there are 2 sentences as the input, sentence A and sentence B, and then the output is label, whether it is an intel paraphrase, whether it's not an intel. So there are only 2 labels, intel or not. Yeah, intel can be paraphrase. Okay. There are 450 sentence pairs for this data. Next task is the single sentence sequence labeling, sequential labeling. The 6 tasks and 7 tasks is the same, is a part of speech task, tagging task. So the idea is to find the part of speech like noun, verb, adjective, and so on for each token in the sentence. So if we give the input 1 sentence, so the output will be, the number will be the same as the token in the sentence. For the 6 tasks, there are 10,000 sentences with 23 post tags. Using the IOB chunking, the post tag standard using the Universitas of Indonesia part of the speech text standard. And then for the second one, the task 7, It has 8,000 sentences with 26 post text. So the main difference is the number of the part of speech tag. In the first one, only 23. The second one has 26 part of speech tag. So it follows the Indonesian Association for Computational Linguistics post-tagging convention. And then the next one is a single sentence sequence labeling also. Both is the span extraction. For the task 8, it is a keyword extraction. And then for the 9th task is the key phrase extraction. In the task 8, we have 5,000 hotel review with 2 span stack, aspect and sentiment with IOB chunking format. And then for the 9th task, it has 1,000 tweets where there's no specific key phrase tag. We just know that this group of token is a key phrase, only that. Okay, there is no information about whether it is an aspect or 7. No, there's only like this is a key phrase. Okay, this is a sequential labeling. Next sequential labeling is the name entity recognition. So before is post tag and then keywords. Next is the name entity. There are 2 name entity tasks here. The first one is has 2,000 sentences with 3 name entity tags, person, place, and organization. And then the second one has 8,500 sentences with 5 name entity tags, people, location, event, product, food, and beverage. Okay. Next is the sentence per sequence labeling. It is a factoid question answering given a question and a passage where the passage is the resource of the answer for the questions. We will have the result of the factoid answer. There are 3,000 sentence pair with 6 question types: date, location, name, organization, person, and quantitative. So this is the example of the input. The input is question and passage. Who is the main counselor of George W. Bush, U.S. President? And then this is the passage. The passage is actually a long passage. We just cut it into the passage with the answer of tokens. This is the answer is Karov. So because Karov is the answer, the result of the factoid question answering, the Karl is labeled by B and the Rov is labeled by I. Okay, so for those 12 tasks, this is the reference paper of those 12 tasks. So we just use the data from these 12 tasks using the same BERT model, just different in the input and output. And then for the data set, this is what we have collected: 23 gigabytes of Indonesian data with 3.5 billion words from 15 sources, which consists of colloquial and formal words. So this is the detail of the data set that we have collected. There are so many, Common Crawl and also Wikipedia. We also collect from Twitter and then from News, Tempo, Kompas, then from Corpus and so on. This is the total number of words, the total number of sentences. This is the size. Okay. This detailed information you can also see in the paper. So the next is the pretrained model. This is actually the one that I think it will be most useful among those 3. Yeah? So we try to compare the BERT with a baseline. So the first baseline is using the CCID FastText by Facebook, 15.1 million parameters. And also we also try to build a FastText model using the Indo4B Dataset, the same parameters, just different corpus as the input. And then this is our proposed IndoBERT. Of course, we use an existing IndoBERT, existing BERT algorithm and existing Albert algorithm. BERT for this, the left one, the IndoBERT, and then Albert for the light one, the right. So for the IndoBERT, we make this base and large, different parameter. And then for the light one, we also build the base and large, smaller parameter, of course. Okay, this is the detail of the pre-training time. How long is it needed? The time needed to build this IndoBird light, and also just the IndoBird, whether this is a base and large. Of course, the IndoBird large has quite high duration, but actually here, using the IndoBird light large, the Albert, because the base size is higher than our IndoBird large, so the time duration is higher also. We have this. One is because the infrastructure that we have. Okay, so we conduct twice here for the maximum sequence length of 128, and then we edit with the maximum sequence length until 512. We divided in the name into P1 and P2. So there are two types actually. Other than these four types, we also have these two types of maximum sequence length, the 128 and the 512. This is the machine that we use for the pre-training. And then for the fine tuning, we use the NVIDIA 300. Okay. This is the result of our experiments and also the analysis. So like I said before, we have this baseline. First, the Scratch. We use the transformer topology without the pre-training. So Scratch here is without pre-training at all. And then just using the one-hot encoding. For the next one, we use this word-to-fact model, the FastText CCID, and also the FastText using the Indo4B and the existing multilingual model. This is very interesting to see the result of these multilingual models. Multilingual models is where the resource for the pre-training is not only for one language, there are several languages in it. So there are 3 multilingual models that we use, the multilingual BERT, XLM, and XLM Roberta. And then this is the result. So this Scratch, this is the one without the pre-training. And then the FastText, using the word embedding of FastText, using the CCID by Facebook, and then Indo4B, where the corpus is the one that we've collected. And then this one, this fourth model, this also the multilingual BERT that already available, multilingual BERT and XLM, Roberta and XLM. And then the last one, the 8th IndoBird, is the one that we've built. We have this light phase 1 and phase 2, and then only the base, phase 1, phase 2, light large, and the large one. Okay. Using the 12 tasks before, the emotion classification, and then the sentiment classification, the aspect base, the textual entailment, and then this is for the sequential labeling for the part of speech, for the key phrase and keywords, for the name entity, for the factoid question answering. If you can see here, actually most of the experiment shows that using the IndoBird, especially the IndoBird large, give higher F1 score. So we use this, the F1 score to make it easier. Most of the tasks has a higher F1 score for the IndoBird large. Okay, even though there are several tasks where the multilingual word embedding model has higher result. Okay, so for example, here we have this aspect based sentiment analysis for the hotel with the SML Roberta, and then for the parts of speech tag with the XLMN only. Even though if we see the result is not too far from the IndoBird large. And also for this name entity recognition, the XML Roberta has higher result. Here in the name entity recognition, our analysis that the training and the testing data has many borrow words, not Indonesian words. So the result with the multilingual model has higher advanced score compared the monolingual one. Okay. So we made also this comparison between performance and space. So if we see here, if we want to compare the parameter and also the F1 score, using a Scratch without the pretrained, of course, it has lowest F1 score and also low number of parameter. With the same number of parameters, similar number of parameter, using FastText has higher F1 score. And if we see here, using the Albert in the BERT Lite, whether it is a base or large, it has higher F1 score, even though the parameter is similar. So, I mean, if the infrastructure is limited, we cannot handle making a fine-tuning using a high parameter, such as used in the XMMR or multilingual BERT or the IndoBERT. We can still use this Albert style. We can use the IndoBERT Lite with quite a good score of F1 score. Okay. So I think it will help a researcher also if there is no enough infrastructure for the research. Okay. We also try with different layers here for the classification and sequence labeling. So we would just want to show the effectiveness of the data sets. This is where we compare it with the Common Crawl Indonesian dataset. So for the classification, using the same pretrained algorithm, the FastText, we can see here that the Indo4B, the dataset that we already called, the 250 million sentence, has higher score compared to the CCID. But for the sequential labeling, it turned out that for only 2 layers, using the FastText CCID has better. But then if we add the layer, the FastText with Indo4B is better. So please visit the homepage in the indobenchmark.com, or you can see also in the github.com indobenchmark. There are also examples of codes that you can easily modify into your NLP task. This is our portal, and then you can also see our models in Huggingface. So to use the models, it's not difficult. Just use like the common codes that you use for other BERT model. You just call the tokenizer, and then you load the model. Then after you load the model, actually, if you want to do directly to classify your testing data without fine-tuning it, you can also do that. But of course, the result will be bad, will have low score. So after you load the model, of course, you have to fine-tuning it first and then try to evaluate it with your test data. So here in the Huggingface, we have 8 models here. Like I've said before, with the phase 1 and phase 2, and also with the BERT algorithm, and then with the Albert, and with base and large. Okay. So if you see in the Huggingface, this model of IndoBERT, they already, here is only 2,300, but before I just saw it in the Huggingface. I think it's like 6,000 or 8,000. I think 6,000 people already download the model. So I believe you don't have to spend resource or time to do the IndoBERT, the pretrained BERT model for Indonesian. Just have to use this one. Just download it and then use the model for your NLP task, for Indonesian NLP task, of course. Okay, this is our folder, the GitHub. You can just go to the examples here. There are several codes show how to fine-tune the model. into a new NLP task. Okay, I think that's all. If you want to see the paper, you can find it in this link, or just search for the IndoNLU. It was published December 2020 in the IGCNLP conference. Okay, thank you very much. That's all for my presentation today. Thank you.
Thank you, Dr. Ayu, for the interesting presentation. We have a discussion time. So from the Zoom chat room, we have 2 questions. The first question is from Mr. Rahmat Izwan Heroza. Thank you for the presentation, Bu Ayu. My question is, how big is the impact of conducting NLP research for Bahasa? Our industries in Indonesia have an interest for the result and support one.
Thank you, Pak Ewa, for the question. There are several startups in Indonesia making product of NLP, Indonesian NLP, and also even there are many industries in Indonesia. They don't produce the NLP product to be sold to other industry, but they use it. Yeah. So for example, in the paper, it is written Gojek, right? Gojek has their own NLP team. So Gojek makes several NLP model for their business. And then conducting the NLP research for Bahasa, for example, this one, the IndoBird. The result of this IndoBird, it has been used by not only by researcher, but also by industries. So industry who has their own training data and testing data for a certain task, for example, the sentiment analysis, because there are so many media monitoring, right? The media monitoring industry in Indonesia. Actually, they can use this IndoBird to build their sentiment classification model. And in my experience, using IndoBirds has much higher result, much higher advanced score compared to other models, pre-trained model there that we have built before. Because you can see the number of sentence, 250 million sentence, the number of words, they're so huge. So industry, they're using it. But of course, because it is free, there is no commercial thing in this IndoBird. Anyone can use it. Okay, I hope that answered your question.
Okay, Mr. Rahmat, is that answer your question?
Yes, thank you very much.
Okay. The second question from Mr. Dani Saputra. Why did you use 2 machines for the training?
Okay, thank you for the question, Pak Dani. So actually the first machine is to build the pre-train, is to build the IndoBird. We use this TPU. And then after the bird model being built, of course, we have to train the NLP tasks, the 12 NLP tasks. The 12 NLP tasks using this NVIDIA. Why the machine is different is just because the infrastructure that is available like that. I mean, using the TPU, actually we use this cloud, Google Cloud, and we have to pay for it. And then for the NVIDIA, fortunately, we have this NVIDIA at ITB. So we can use this DGX1 machine to do the classification. So actually, yeah, the reason is not scientific. The reason is very practical.
Okay, thank you. I was just wondering about, is there some difference between the machines?
Actually, yes, but
it's more of price, isn't it?
Yeah, of course.
Okay, thank you.
You're welcome.
Okay, there any question, more question, maybe from the offline participant?
Yeah, I really hope that the result from this research, the bird model, the Indo bird model, you can use it not only for research, but you can also use it in the course. You know, if you have this NLP course or machine learning course using the deep learning and so on, you can just use this model. If the infrastructure is not good enough, then you can use the light one, the base and light one. There is a question from Buno.
Okay, that's the answer for Mrs. Novi's questions. And we have another question from Mr. Ricky Aji Pratama. What an interactive presentation. My question is, would you give us insight how to implement the model into hot news detection with this NLP model?
Okay. Actually, in any kind of classification, if you want to add the sense detection in your hoax news detections, it means that you compare two sentences, right? One is like a new news, an input news, and the other one is the reference news that you already know whether it is a hoax or not. Then if you conduct this sense detection, actually it is similar with the entitlement before, the sentence pair. So using this IndoBird as the pre-train, you just have to fine-tuning it, and then the input divided into the the news that you want to check, and then the reference news, and then the result, the class will be like entail, or perhaps support, or reject, or irrelevant, something like that. If you use the sense classification in your hoax news detections, actually it depends on the structure, on the architecture of your hoax news detection.
Mr. Ricky Aji Pratama, how is the answer? Please give a feedback.
Welcome.
Okay, thank you. From
there is a question from Miss Novi. Question generation.
From Miss Novi, I haven't read yet.
Oh, okay.
Okay, from Ms. Novi Yusliani, I'm sorry, Ms. Ayu. The question is out of the topic. In question generation, what method can be used to classify complex sentence to choose the right question to generate?
Oh, question generation. Classifying complex sentence, yeah. If you only want to use pre-trained BERT, I think you can still use the pre-trained BERT. But then again, you have to have this training data of pair of sentence and the label of whether it is a complex sentence or is simple sentence, or perhaps it is like imperative sentence and so on. So you have to have this kind of data. But in the other hand, sometimes I think to classify whether a sentence is complex or not, I think you need like a parser or something to extract the structure of the sentence, whether it is a constituent parser or a dependency parser. So that way you can get this complex sentence easier than without the information of the syntactic. Okay, perhaps we can discuss this further, yeah, Bu Novi.
Okay, Mrs. Novi Sulaiman, how is the answer? Or maybe you can discuss privately later. Okay. I think that's. Is there another question? Okay. I think the answer for Mrs. Novi's questions will close the discussion and this session. Thank you. Dr. Ayu for the presentation and also the discussion. I hope someday you will visit Palembang.
Yes, I want to.
It's very informative, interesting presentation, also a discussion.
Thank you. I hope
Yes.
it is useful.
Yes. Okay, please give applause for the speaker. Thank you.
Thank you.
Assalamualaikum warahmatullahi wabarakatuh.